means to say what? What does it represent? You need to send it, right? That is only one task I am giving. That also you are not doing this. What does it mean? Okay. So in yesterday's class, I told you about amino acids. So and I shared slides too. Have you seen it? Not proteins, till carbohydrates. What we finished. So protein slides I'll send it now. After the class I'll send. Please go through the what to say slides and see your videos. Make running notes and make use of all these things because you know nowadays we are facing with a lot of problem with our educational department. So you need to read. So and one more thing, in your syllabus of 10th and PU board, they were cancelling 35 to 40%. There has been noticed in the news and all, announced in the news and all. But the thing here, they need to give the notifications like which are the lessons which doesn't there and which is not have the weightage of the classes and all. But till now they didn't send it to the college. I'll inquire that. Anyway, we have a meeting. So on this Saturday, I think so. So I'll inquire on that day, and I'll get you know that what are the concept and what are the things. Okay. So that is the thing I need to share with you. Then apart from that, I think we are okay with all the things. Anyway, we are doing biomolecules. So maybe from the October 1st, the chances is October 1st. If it is possible, they'll open it as soon as possible. Because in the initial days, they used to say from September 1st, the college has been reopened. But now they were saying it's from the October 1st, it will release. If that is the rule, maybe the chances of cancelling the lesson is still your October portion. Means to say we have a schedule, right? So that schedule, in that schedule, we have in this month we need to do this lesson, we need to do this lesson like that we have. So that May till October, that scheduling, based on that scheduling, maybe your lessons has been cancelled. Maybe we are not sure, but we are thoughting like that. Okay, fine. In the last class, I told you about the protein. So the protein is made up of amino acids that is helpful for the building blocks, and that will give you the protein is an living component of a cell and essential for the growth. And in the Greek, we are getting that word called proteos. That is that means to say it's a first. So and the composition of what to say the composition of your amino acids. So composition of protein is your amino acids. So we have 21 types of amino acid, and it having the structure like this. 4 different groups are attached to the carbon atom. So we can say this carbon is an chiral carbon. The amino acid is an chiral. We can say the amino acid is an chiral carbon if it is R is replaced by any other group rather than these 3. We can say amino acid is an chiral compound if it is this R group is not replaced with any of these 3 groups. Then we can say it as that is chiral carbon, chiral compound. So in the one side we have ammonia NH2, the other side carboxyl group COOH. One more side is a hydrogen, and R is a functional group. It can be replaced by any of the molecule. So and we have the amino acids. In the nature, we are getting 20 20 alpha amino acids. In nature, we have, in nature, I'm saying, in nature, we have 20 naturally occurring amino acids. So we usually represent the amino acid in the terms of AA, amino acid. So, okay. So amino acid has been classified into two groups. Amino acid has been classified into two groups. That is essential essential amino acid, and non-essential amino acid. So you are thinking, I think so, like, essential means we required, fine. If we don't require, why we want to study? Why we are required it? That is not like that. Essential means we need to require for the body. It is not there in the body, then only we required. So that's why we need to take up this with our diet. Okay, are you getting my point? So we need to take up this essential amino acids through diet, because it's not present in our body. Suppose if it is present in our body, then why need to take it from outside? For example, if you're going to meet a doctor, so doctor saying like, oh, madam or sir, you are deficient with an vitamin, so you need to take the tablets, or you are deficient with calcium. So what does it mean? It means to say how much required for your body, that much component or that much you don't have. So that's why you need to take it from the outside. That is called it as essentiaries. Essentiaries. So we are taking that components from the outside. So from the out resources, we are taking out of it. Yes, Gokul, they'll surely reduce, because that announced in all the newspapers and newses and in all the medias, everywhere. You just go through the, not yesterday's, day before yesterday's, no, sorry, yesterday's paper, and you can see the notifications and all. They'll surely remove the 35 to 40% of your PU and 10th, both syllabuses. Okay, fine. So this is called as essentials. So and non-essential means to say what is just ulta for the essential. It means to say it's present inside our body. We no need to take up from the dietary inputs. So it is present inside our body. Okay, so we no need to take up from the outside. So these are the two components or two types of amino acid you have. So how many essential amino acids we have? How many non-essential amino acids we have? Usually, if we are considered the natural compound, it's of 10-10. We are considered it as 10-10. But if you are go through the books or go through the higher studies and all, they'll say the essential components are 10 and non-essential are in the 11 number, because 10 plus 1. So we have totally 21 amino acid. So in that 21 amino acid, 11 is your non-essential amino acid. Just a second, Megan asking something. Yeah, Megan, is it that position of amino group should be opposite of carboxylic acid group? It's not like that. It's not sure. Like we are saying, this both should be in the opposite side. Okay. In some time. Okay, in some time, it may having the repulsive force, so it may come here. But in most of the cases, and in most of the time, it will be in the opposite side. Why? Because you have one problem called steric hindrance. Okay, steric hindrance. So what I mean by steric hindrance means, steric hindrance is an type of phenomena. Okay, steric hindrance is a type of phenomena where if the heavy molecules are attached one next to the other, suppose I'm showing here, if these two are attached, this is next one next to the other. Okay, these two are one next to the other. So what happened? If these two are heavy molecule and this is attaching one next to the other, by the force, if it is come nearer and the angle between them is less, what happen at that time? It may create repulsion and it leads to the breakage from the atom. So it leads to the breaking of the bond from your atom. Suppose you can see this, right? So this is one carboxyl group. This is your one more group, and this is ammonia. Just think like that, okay? So here this side in the fourth position you have one more component. Okay. Just but it's homework. Almost all the structures that have written are present in adjacent side. Yes, that only I'm saying. That only I'm saying. I'm trying to explain. So okay. So if it is comes nearer, it reduces the angle between both of it. Okay, when it reduces the angle between, it start repulsing and it will break the bond of it, and this ammonia or carboxyl group will separate from your carbon. So that's why, for the safer side, and in most of the things, we are going to write the ammonia and carboxyl group in the opposite direction, not in the same direction. When we'll write, if this R group is more heavier than these two, okay, if the R group is more heavier than these two, we can write the ammonia here, carboxylic here. When I'm saying this R group is heavier than these two, at that point we can write. And most of the things I'm telling you, for our convenience, we are going to write like that, because upon the top we can't write so much. Upon the top we can't write so much. So for that, what they'll do, they'll take up the right side or left side and they'll rotate like this. Okay, they'll rotate like this. Because of our convenience, we are made it like that. But usually the amino acids are present like this only, because you have one word called zwitterion. I'll explain that. In that, if I wrote, you can understand it better. I'll tell you why I am saying this should be in the opposite direction. Yes. Now let me move on. Biological importance of your amino acids. Yes. Biological importance of amino acids. So what are the biological importance of your amino acid? So the important is, first, it will help for the building of your protein. Building of your protein. Yes, fine. Then it's help for the growth of the cell. Growth of cell. Okay, then it's play a major role in the synthesis of your enzymes. Synthesis of enzymes. Okay, so this and all the actual and major importance of your amino acids. Okay, shall we move on to the structures? Shall we move on to the structures? Okay, Meghana, you understood, right? So I'll explain it in the zwitterion. You can understand it better. I'll explain. Shall we move on? Yes, fine. I need to give you this protein part of writing it, like running notes. Just give me a second. Okay. Fine. Now we are going to take up with the structure of amino acid. So yeah, as I told you, you have 21 amino acid, but we need to read only 20, no problem. So first, the amino acid has been classified into acidic amino acid, basic amino acid, and neutral amino acid. So amino acids are classified into acidic amino acid, basic amino acid, and neutral amino acid. So when the H plus is increased, that is acidic amino acid, when H plus is decreased, that is basic amino acid, you don't have H plus molecule, that is your neutral amino acids. Okay, then one more type we have, that is, this is one type of classification, this one is second type of classification, this is saturated, or you can say aliphatic amino acid. Second one is aromatic amino acid. So we have so many types of classifications in amino acid. First we read in the previous thing, that is based on the essential and non-essential, means we need to take it through diet or not. Based on that we have classified into essential and non-essential, and now based on the presence of H plus we have classified it as acidic, basic, and neutral, and based on the presence of your functional group we are classified it as aliphatic amino acids and aromatic amino acids. So you need to know this and all types. So now I'll give you an assignment. I'll write the structure of all the amino acids. You need to notify, you need to rectify whether it will come under acidic group or basic or neutral, or in the same way you need to say it whether it is aliphatic or aromatic. Aliphatic means that doesn't give you an aroma and it is straight chain. Okay, straight chain. This is ring. Okay, this is ring structure. The meeting will end up in 10 minutes. You please relog in with the same ID. Relog in with the same ID. Okay, aromatic is ring structure. Aliphatic is a straight chain. Fine. So now I'll start writing the structure one by one. First, we have glycine. Okay, glycine. We used to represent in the three words called GLY. So you have the structure like this. You can write like this also, no problem. So now I have one question. This is your glycine structure. So now I have one question, that whether this is chiral carbon or not. Whether it is chiral carbon or not. Please answer it fast. Whether this is chiral carbon or not. Next is alanine. No. Yes, Gokul, you are right, because it having same group in both the sides, that is H, that's why it is not an chiral. Yes, you are right, and you are perfect, Gokul. Next, the second amino acid is your alanine. So we used to represent that ALA, alanine. So everything remains the same. So you don't no need to worry about these three functional groups. So you need to only change this R. So this R is replaced by CH3, amine group. Sorry, methyl group. This is methyl group. So this is your functional group, CH3, alanine. Okay, next one. Whether it's aliphatic or aromatic, or acid or base or what? Please tell me fast. And essential or non-essential? Alanine belongs to which classification? Whether it is aliphatic or aromatic. Next one is phenylalanine. Phenylalanine. We used to represent in the three words called PHE. PHE. So it will remain the same. You can write my structure or your book what they were giving the structure, so no problem. It's completely depend upon you. So this is entire is your functional group. This is called CH2 and your benzene ring is called phenyl. So when your amino group is combined with your phenyl, that will give you an phenylalanine. So alanine andre idalva, CH3 is your alanine. So one hydrogen is replaced by your phenyl group. Sorry, one hydrogen is replaced by your benzene ring. That's why it will become phenylalanine. That will become phenylalanine. Tell me whether it is aliphatic or yes, Meghana, you are right. This alanine is your aliphatic and phenylalanine is your aromatic amino acid. Very good. Next, let us see the fourth one. Valine. V-A-L. Valine. So it remains the same. You should write, or you're writing, or you are doing fun. I'll just because of my convenience, I'm shifting it down. So I'm just shifting it down because I need to write the chain. So this is your functional group. You can name this functional group by the nomenclature format. You can name this functional group. This you have 1, 2, 3 prop, single bonds, propane or propanol. You can say propane. Okay. So when the functional group is CH3 is fixed with your amino group, that will give you an valine. That will give you an valine. Whether it is aliphatic or aromatic, acid base or neutral. Do one thing, acid base neutral, we'll study it in later time. Yes, Meghana, that only I need to ask. How to guess whether it is acid basic antana? For that, suppose here the H plus are in more number, right? So it is acidic. Valine is an acid amino acid, acidic amino acid. Suppose this phenylalanine is having the ring, so it doesn't come under your acid or base. So that's why it is neutral. So see the alanine. Alanine is CH3 methyl. Here also the H plus number is more, so it is acidic. So if the H plus number is more, okay, H plus number is more, then you can say it as acidic. If H plus number is less, then it is basic. If it is not compare much, so that is neutral component. And you're asking, Gokul is asking one thing. I have it cleared, Meghana? Does it fine? Gokul asking like how we can say whether it is aliphatic or aromatic. I told you, right? If it is presence of ring, if it is presence of ring, that is aromatic. If it is presence of benzene ring, I can specify like this also. If it is presence of benzene ring, that is your aromatic component. If it is ring is not present, if your ring is not present, that is aliphatic. Straight chain like this. Where here straight chain like this, if it is present, that is aromatic, sorry, that is aliphatic. Ring, that is aromatic. Aroma means fragrance. Is it okay, Gokul? Then again Meghana, yes, valine is your aliphatic, right, Meghana? So we have to find the number of H plus in our group. Yes, perfectly, because the amino and carboxylic are balanced out. So if we want to calculate, we need to calculate it only for our group. Because for all the amino acids, your amino group and carboxylic group remain same. So if you compare that, if you count that also, you don't no need to have think about the much more differences. So you can skip those and you can calculate, or you can take only the R group. Is it fine? Shall we move? Okay. Next, isoleucine. Isoleucine. I-L-E. 3 letters, we used to write it as I-L-E. And I'll write like this. Okay. CH2, CH, CH3. Sorry, my mistake. Yes. Here you can write like this also. Yes. You can. I'll show you again. Valine. You can replace. Yes, Gokul. Is it? It's aliphatic. Isoleucine is aliphatic. Isoleucine also an acidic amino acid. I'll tell you that how to detect that you have a list of acidic amino acid and basic amino acid. The 6 are there. You can remember it very easily, no problem. So I just rewrite it. CH2 CH, instead of in a triangle manner, I write it in a straight chain for the better understanding. CH3. So here 1, 2, 3, 4 right, 1, 2, 3 right, 1, 2, 3, and 4 right. Yes, this one. So you can see the straight chain now. So this is your leucine. And here it's your isoleucine.